Hi folks, Vipin here. Today we're going to discuss about inventory theory. Now for the entire unit I'm just going to do one problem, and I hope once I'm done with the problem you understood the whole of inventory theory. Now I'll make sure that you guys have actually understood the whole problem in fact and the whole unit. So don't worry about it, I'll be able to wind up this unit in just one problem. Now, that's something which I've always told people who are doing statistics or mathematics. Don't practice too many problems because that's a sign of being inefficient. If you are someone who's doing books together worth of problems, that's just showing that you lack efficiency. You should be learning it in such a way that one problem is good enough for you to know the whole unit. So that's something which I'll make an attempt here. So for inventory theory, I will be doing problem number 16 in the Rajmohan book. So I'll quickly read out the problem. I'll anyway give a description about the problem in the comment in the description box. A manufacturer requires certain raw material at the uniform rate of 16 tons per year. Ordering cost is rupees 200 per order. Carrying cost is rupees 40 per ton per year. If shortages are not allowed, what is the most economical inventory policy? If shortages are allowed, the shortage cost being rupees 100 per ton per year, what is the most economical inventory policy? Now, when they go about asking you what is the most economical inventory policy, you should in fact do all the formulae that has been given in the book. Okay, there are around 6 formulae if I'm not wrong. It's good if you can do all the formulae that is there in the book, and then that's how you go about solving this problem. Now I like this problem number 16 because they've given both the shortages being allowed and the shortages not being allowed. Now, basically, what inventory theory says is that there are two different models for you to do business. Okay, you can do your business in two models. The first one, wherein there is no shortages at all, that is the stock that you have, the raw materials must always be full. They have to be full. But in the second one, there is shortages, and it's okay to have shortages. Okay, and when you have shortages, how would your stock be like? And when you don't have shortages, how much of stock are you supposed to have? This is what inventory theory broadly talks about. Now, I'll explain all the different terms that they use here by talking about problem number 16. So, let's do problem number 16. Now, let's look at the first side of the problem. That would be, it says, if shortages are allowed. Sorry, if shortages are not allowed. If shortages are not allowed. Now I prefer to do it because I prefer to do this one first because many of the values that I'll be able to get here, I can in fact substitute in the second set of formulae, and it becomes so much more easier when I do that. Okay. Now, firstly, let's look at EOQ, economic order quantity. Now this is in fact given as Q naught equals the square root of 2C3R divided by C1. Now, I've not really written the data of the problem before. I'll do that now and I'll explain it as I write it along. First bit of data I'm going to write will be R, which happens to be 16. R here, if you read the formula, if you read the problem, it says a uniform rate of 16 tons per year. So 16 tons would be the demanded quantity. So R here is in fact the demanded quantity. Okay. The next thing that I'm going to write here is the ordering cost. The ordering cost here happens to be rupees 200 per order. Ordering cost here is given as C3. So C3 is going to be 200. Okay. The next thing that you have there would be the carrying cost. The carrying cost here would be C1, and C1 here would be 40. Okay. Now there is one more that is there in the later part of the question wherein they say the shortage cost being rupees 100 per ton per year. Okay, 100 per ton per year. Now that is given as C2, and C2 here has been given as 100. Now let me explain the four terms that you will find here. R being the demanded quantity, that is, you want 16 tons of raw material. Okay, that's the amount of raw material that you have requested. It could be for an entire year, like the question says, or in reality, it could be, say, on a weekly basis or on a daily basis, whatever type of business you're conducting. Okay, C3, which is considered as the ordering cost of rupees 200 per year. Ordering cost would be the amount of money you spend in calling up the suppliers and telling them that this is the quantity that I want. It could be printing of the invoices, it could be the uh, basic paperwork and the filing work that you need to do, or paying the person who is in fact doing all this. That could be considered as the ordering cost. Carrying cost is rupees 40 per ton per year. Now, carrying cost can be in fact related to transport. How much would they charge you in order to get the raw material from the supplier's location to the required destination where you're doing your operations? Shortage cost would be how much of money would you lose in your business in case in fact you have a shortage of raw material. So that's in fact represented as the shortage cost. Okay, now I'm just giving you the theory from a broad point of view, because in the textbook it doesn't really say what type of business you're doing. So these terms in fact have got very varied definitions depending upon the type of business you're into. So first one that you have here would be the economic order quantity. Okay, now that's been represented as Q naught, which is equal to square root of 2C3R divided by C1. Okay, now if you were to substitute the values that is here, okay, you should be able to get 2 multiplied by 200 multiplied by 16, that would be the order quantity, divided by 40. Now this would come as 12.6 something, but keep it as a whole number as 13. I tell you to keep this as a whole number because it makes your further calculations easier. Okay, you can keep 12.64 if you want, but not advisable. It makes your calculations a little difficult later. Now let's look at the reorder time. Okay, the reorder time here is represented as T naught, which is equal to Q naught divided by R naught, which is 13 divided by 16. It comes to 0.8125 years. Okay, 0.8125 years. Then I told you by using a whole number here, this becomes easier to calculate. The next thing that you have would be frequency of replenishment. Frequency of replenishment. Now, this is not really required to calculate, but I'm doing this because so that you understand the whole inventory theory formula. Okay, frequency of replenishment is given as N naught. N naught is equal to 1 divided by T naught, which is in fact 1 divided by 0.8125, which comes to about 1.23 years, which means you'd be restocking your inventory every 1.23 years. Okay, and then the minimum average cost, that would be minimum average cost. Minimum average cost is given as this equals the square root of 2C1 C3R. And now I hope I don't run out of space when I do this. Square root of 2 multiplied by 40 multiplied by 200 and multiplied by 16. This should give me rupees, I'll write it here, rupees 505.96. If you want to round it off to a whole number, it's okay, but I've given it as 505.96. Now, there are other formulae that would be there in your book, but those don't apply for this particular model. Okay, like if you look at the maximum inventory, that doesn't apply to this because the maximum inventory will always be 30. Okay, you have a policy wherein shortages are not allowed. So in other words, it's just another way to say your inventory will always be full. So this is the first side of the model that you have, where shortages are not allowed. Now, once again, I'll run you through all the different terms that is used here. Economic order quantity would be the best possible order that you can place at the least possible price. Okay, then reorder time. How often do you reorder? Okay, that is how long does it take? 8.8125 years. Sorry, frequency of the replenishment. That is how often do you have to get this 13 the quantity back into your stock regularly. Minimum average cost. How much does it cost you for placing this order? That would be 505.96. Okay. Now this happens to be the formula that you would use in case it is model 1. Okay, this would be something that you would be using in case it is model 1. Now, using the same bit of data and some of the answers that you've got in this, you can in fact find the other side of inventory theory, wherein if shortages are allowed, how would you go about calculating these different values? Okay, I've not erased the data here. I'll consider this as model number 2. Okay, and now model number 2. How would you go about considering if shortages are allowed? Now, the first one again, we'll look at EOQ, economic order quantity. The first formula here. Now, EOQ gets slightly lengthier here when you go about calculating. Okay, the formula here would become the square root of 2C3R divided by C1, multiplied this by the square root of, one moment, I need some more space here. Yeah, C1 plus C2 divided by C2. Okay, this is the formula that you would use. This extra bit of formula that you would use would be in case of model number 2. Okay, if it's just model number 1, you can ignore all this and this is all that you'll be calculating. Now, since I already know this bit of the value, all I need to do is pick it up from the previous answer. That is nothing but 13. 13, if I were to multiply with these values, that is C1 would be 40. 40 plus C2 would be 100. 100 divided by 140. And this is what I'll be able to get. I should be able to get around 15 in this case. Okay, again, if you come across a fraction here, a decimal, sorry, you can round it off to a whole number. Okay, like I said, this makes your calculations later on easier. Now, the reorder time here would be T naught, which would be equal to Q naught divided by R. Okay, T naught, Q naught divided by R. Now 15 divided by 16. Q naught would be the one that I'm getting in this answer. Okay, now this would give me 0.935, now 0.9375 years, sorry, 0.9375 years. This is what I should be able to get. And then frequency of replenishment. Now this is given as N naught. N naught would be equal to 1 divided by T naught. 1 divided by T naught is nothing but 1 divided by 0.9375, and this should give me 1.06 years. 1.06 years. Okay, and now coming to the other ones that gets a little bit lengthier, the minimum average cost. Okay, minimum average cost, like I said, is given as CQ naught. Now here again the formula gets slightly lengthier. The same old one which you have used in model number 1, that would be 2C1 C3R multiplied by the square root of C2 divided by C1 plus C2. Notice how the shortage cost here will be included in model number 2. Okay, so Here what I'm going to do, I've already got the value here. In the previous answer it was 505.96. Okay, 505.96. Now if I were to substitute the values here, C2 would be 100 divided by 40 plus 100 again. This should give me the answer, which is rupees 427.61. Okay, rupees 427.61. This is the minimum average cost. Okay, then there are a couple of more formula that I need to work out here. So I'll quickly erase this and I'll discuss them. So here, now in model number 2, you have more formulae because you are allowing shortage in this particular model. Okay. Now, what is meant by a shortage here? Now, every business has got a tolerance limit. Okay, every business has got a particular tolerance limit. Let's say this were to be the overall quantity that is there in the business. Okay, this includes 100 tons of raw materials. Now I'm explaining shortage here. So this includes 100 tons of raw materials. Now every business will be like, okay, today we're going to use this much. It's fine. Tomorrow we're going to use this. Day after we're going to use this. And over a course of time, we'll slowly be using this. If this were to keep depleting, to what extent can we allow this stock to deplete? They all have a tolerance limit. If they say, if the stock comes to this much quantity, we need to urgently go about placing an order. We need to urgently go about place an order. They have computers that do this work, but this is just the theory behind how they actually work. If it comes to this much quantity, we urgently need to place an order. Now, when they do this, they're actually allowing a shortage. There are some businesses wherein each time you see this one bar being reduced, they replace this with new stock. Now that's also okay. Even this also happens to be okay. But this is a slightly riskier model because you're allowing stock to fall down to this danger zone. And then afterwards, you're actually placing an order. Some businesses prefer to be safe, wherein continuously, if this happened to be the quantity of raw materials that they have, even if this much is reduced, they will go about placing an order right away. Now, like I said, it's all a matter of the type of business and the policy that they have. But some businesses will prefer to go down to this mark, while others will be like, it has to be 100 tons of inventory throughout the day. There are even accounting practices that they follow for this. They call it as the LIFO method, the FIFO method, all that. So depending upon that, they can either go about placing an order when it comes to a shortage, or they can never have a shortage at all by considering this model. Remember, each of them have got their own pros and cons. It's all up to the business when they want to do this. Okay. Now, coming to the remaining formula that would be there in model number 2, that would be now you have maximum inventory level. Maximum inventory level. In the previous one, the maximum inventory level would be nothing but EOQ. That would be around 13 tons. Okay. Now here, because you're allowing a shortage, you consider a different way of calculating the maximum inventory level. S naught equals C2 multiplied by Q naught divided by C1 plus C2. Okay. Now this should give you 9.28. Okay. 9.28 should be the answer that you should be able to get. This is nothing but C2 would be 100 multiplied by Q naught. This is Q naught in case shortages are allowed. So Q naught would be 15. 100 multiplied by 15 divided by 40 plus 100. You should be able to get 9.28. Okay. And then the maximum shortage that can be there. The maximum shortage that can be there here. Now here, this is calculated by Q naught minus 8 S naught. So Q naught, if you remember in the previous one, would be 15. 15 multiplied by 9.28. 0.28, you should be able to get 3.72. Now this is what inventory theory is all about. If you know the different formula and simply substitute them, you should be able to get these answers. Okay, don't really worry about all the theory that is there in this. I would suggest that you do one problem in this, because as far as I noticed, all the problem in fact in this happens to be the same. There is hardly any difference between one problem and the other. So if you are able to go through this, okay, if you're able to go through this, you should be able to answer all the questions that would come from this unit. And if I'm not wrong, this unit doesn't really have a very high weightage, and this unit happens to be ridiculously easy. Okay, if you do have any queries, let me know. If you want me to work out more problems in this unit, let me know. Thank you for your time and have a nice day, and please subscribe to my videos. Bye.